In this section, we're going to work a lot with vocabulary. We're going to talk about what it means to work with sets. A set, remember, is a collection of distinct elements. A subset contains the elements from the set. So there's going to be a couple of ways of writing these. Anything denoting a set as the little squiggly parentheses around it, the braces. For a roster form is when we're going to list elements within the set. So for example, I would say that the set, let's say the set M, consists of all the numbers up, all the integers, let's say all natural numbers up till 5. So I would say it's 1, 2, 3, 4, and let's say it included 5. My answers would be possibly 1, 2, 3, 4, or 5. So the roster form, since it's listing all the values, becomes a little bit easier to be able to describe. A set builder notation works with things that are a little bit broader. So what we always do is saying, okay, the set M is going to equal a value of X such that, this little line here means such that, and we say that X is a natural number, or X is a real number, and that X is, say, greater than or equal to 3. So it's a little bit more cumbersome. There are some abbreviations that can happen. A lot of times this phrase right here is not necessarily included. That we'll just say X such that X is greater than or equal to 3. It's understood to be the set builder notation. But you have to have the brackets and you have to have that line for such that. Called an empty set. Okay. And we've talked a little bit about this before in saying that the no solution, which is this, the 0 with the line through it, actually is a fancy way of saying it's the empty set. There are no solutions. There is no set of answers. What we'll also sometimes do is use the brackets with nothing in it, which once again means empty set. Probably not, don't use that as much. Okay. There's also some fancier when we talk about subsets. Let's say A, I'm doing great. A being a subset of B means every item or every element of A is also in B. And once again, this is a fancy way of saying A is a subset of B. So let's give you an example of this. Make this a little bit smaller. Okay. Let's say A is going to be let's say A is equal to the subset of the values of 1 and 2, and let's say B is going to be the subset of 0, 1, 2, and 3. In this case, every element of A is also an element of B. Going back to some of what we learned in sort of using Venn diagrams in a sense, what we can think about is that we have a universal set given by this whole entire thing. It's the universe. Okay. This is called the largest set possible. It's usually one whole answer. Okay. If I say that this is A here, what I can say is that there is also, when I'm looking at the universe here, which is like the whole range of possibilities, if I have this being A here, what I'll say is that the outside of this here, shaded in green, is what becomes called the complement of A. What I mean by the complement of set A is all the values or elements that are not in A. Okay? So for example, if A is, say, weekdays, Monday, Tuesday, Wednesday, Thursday, Friday, the complement of A would be the weekends, Saturday and Sunday. So together they make up the whole, say, week, the whole universe, the whole universal set, that largest possible set. But it's either A or the complement of A. So right now this is probably, might be a little bit confusing. It's all basic vocabulary. It's some information that we're going to be using in the next few sections, but I want you to begin to get familiar with the vocabulary.